Hello, this is Brianna Samaniego, and I will be working with three fourth-grade struggling math students for Assignment A. This is the problem I chose for the students, as it reads. The city bus left the terminal and picked up 6 people at the first stop. At the second stop, 2 people got off and 3 people got on. At the third stop, 2 people got off and 3 got on. How many passengers were now on the bus? Explain your thinking using numbers, words, or pictures. I did not give any assistance to the students other than slowly reading the problem to them to be sure they understood the wording of it. From there, they were on their own. I was intrigued by this approach of giving a student a word problem because math is not usually taught or done that way. As stated in the Van D. Wally text, children in traditional mathematics classes often describe mathematics as imitating what the teacher shows them. So for this problem, they did not get any assistance and were able to do it on their own, using their own methods rather than mimicking what they are shown and told. For this reason, I was excited to see the way in which each individual student completes a problem as well as their thought process. Student A was very hesitant to start the problem and ended up being the last of the 3 to complete it, because I noticed from his work that he had started a method of completion, then changed and used a different method. At first, student A had disregarded the words in the problem and just focused on the numbers and writing down 6 minus 2 plus 3 minus 2 plus 3. Representing the coming and going of each person getting on or off the bus. This student would have come to the right answer if his math was correctly articulated, but he had done the math steps out of order instead of going left to right, so he ended up getting a negative number. After that, I could tell that he knew on his own that this was wrong. He then set up an equation by first focusing on the passengers getting on the bus, so once he added those getting on, which came out to 12, he then took into account those whom got off and subtracted those from the ones who got on, which ended up being 12 minus 4, and his final answer was 8, which is correct. Student A used common conceptual understanding, being that he knew that things were being combined in the problem. So while originally the setup of his problem was correct, the articulation of his work was off, which can also mean that this student's procedural skills may be off. So once he then just focused on the conceptual understanding of combining the amount of passengers whom got on and then subtracted the amount that got off, he arrived to the right answer. Although this student's procedural skills may have lacked in the beginning, he used adaptive reasoning to realize that the first answer he got was incorrect, so he redid the problem and then got the right answer, which is great to see. Student B was very quick to complete her work and ended up being the first to finish with the correct answer. Student B's approach was much like Student A's, except her procedural skills were much better in the fact that her work was done correctly, which got her to the right answer being 8. The difference in the way that Student B completed her work and got the right answer compared to the way that Student A did the work and got the wrong answer is that Student B was much more careful and concise in her work by moving from one group, getting on and off to the next, rather than putting it all together at once. So Student A's conceptual skills of combining and connecting one set of numbers to the next was much more effective. Student A started off by subtracting the original 6 who got on the bus and then subtracted the 2 whom got off, and her answer was 4. She then added the 3 who got on and got 7, and then she subtracted the 2 who got off and got 5, and then she added the 3 who got on and her final answer came out to 8, which is correct. Student C completed the problem much different from the other 2 students, being that she used manipulatives in order to complete the problem. The manipulative Student C used was drawing a picture in order to figure out the problem. Student C started out by drawing a box, which I assume represents the bus, and then drew out 6 circles, which represents the 6 passengers whom originally got on the bus. From here, Student C uses a very different approach to then solve the problem by, rather than starting new from the resulting number, she just adds and crosses out circles to represent those getting on and off the bus. So after the 6 that got on, she crosses out 2 representing the 2 whom got off, and then adds 3 more circles representing the 3 who got on. She then crosses out 2 more and then adds 3 more to represent again the 3 new passengers that got on. At the end of the adding and crossing out, she then added up the circles that did not get crossed out, which would represent and equal the passengers whom were on the bus at the end, and she got 8 passengers, which is correct. So while Student C did use manipulatives to work out the problem, her conceptual understanding of combining and adding passengers was spot on, which brought her to the right answer of 8. Overall, all the students came to the right answer being 8, which I was pleasantly surprised about because my mentor teacher had said they were the students who most struggled in math. I was also pleased to see the way in which each student completed the problem. I also enjoyed seeing the different approaches that each student took, being that some used manipulatives and pictures while others wrote out equations to solve the problem. I noticed that overall, in the end, each student procedural skills were decent and led them to the right problem. Even though student A originally got the wrong answer, he did use adaptive reasoning to realize that he got the wrong answer and change it to get the right one. I also noticed that each student took apart the problem, or at least tried to, rather than just counting on their fingers like I thought they would. I enjoyed watching them mostly go from one step to the next to ultimately arrive at the right answer. I also noticed that each student's conceptual understanding was overall very effective, as they understood that they needed to combine by adding and also subtracting the passengers who got on and off the bus. To be honest, there weren't very many common errors or mathematical misunderstandings, being that they mostly got the problem correct right off the bat after working it out. The only common mathematical misunderstanding that I did see that I do think is common in students is when student A went to work out the equation he had written out. Instead of going from left to right, he oddly did his math out of order, which I think is a common misunderstanding that students do often. Even I catch myself doing it sometimes as well. If I were to give these students another problem, I would definitely make it harder because I feel that they were easily capable of completing this problem. I would also build upon the knowledge of this problem and add some unnecessary information into the word problem because I would be curious to see if they got stuck on that information or if they could overlook it to focus on the important information to solve the problem. I would also strongly encourage students to use manipulatives like pictures or provide them with blocks to see how they use them in order to solve the problem, or if they would rather just write out an equation, depending on what they prefer. I was very happy and pleased with this project because it allowed me insight into some of the students I will be working with this semester, as well as understand the thinking process of students at their age.